Okay, so thank you once again for everyone for joining us, whatever time of day it may be where you are, for this 5G wireless wireline convergence work overview. Just to do some housekeeping to start off with, just to let you know that we will be recording and making that recording available to all of you via email after this event. And we'll also be having a PDF version of the slides for you to utilize after the event as well. In regards to if you have any questions for our panelists today, please do utilize the Q&A section that you can find in the bottom middle of your Zoom webinar to enter any of your questions. That allows us to make note of them, and if we don't have a chance to answer all of the questions, then we can do it post-event if you can put it in that Q&A section. And then lastly, if you are interested in the work of our WWC project area, we would actively encourage you to join us, and we will make some links available in the chat for you to see how to do that, either by entering info@broadband.forum.org as an email address, or to contact Rhonda Heyer, who's our membership director. And following that, we will also be having on the week of the 22nd of March, our Q1 meeting, where if you would be interested in more information and see how the WWC is doing, please do contact Rhonda Heyer again, and I'll put the details in the chat, and she can organize a guest pass for you for our meeting if you aren't already, obviously, a Broadband Forum member. Right. That's the housekeeping out the way. Now let's move on to the order of the day, our 5G wireless wireline convergence work overview webinar. My name's Craig Thomas. I'll be moderating today's session. And joining me, I have an esteemed panel of experts that all have one thing in common, well, probably many things in common, but one specific thing in common relative to this webinar. They are all instrumental in our work in driving open standards and contributing to our work in open standards in realizing a converged wireless wireline network. So joining to me today in order of presenting, we have Christele from Nokia, who's the standardization and strategy of technology within Nokia and also a BBF innovation director. Also from Nokia is Laurent, who is a senior standardization expert. He heads up the Nokia team within the 3GPP organization, specifically in SA2. And then joining us at what is a horrible hour for him in Australia is David Woolley, a network engineer and planning and a senior lead inside Telstra. Following David will be Rosaria from Telecom Italia Mobile, or TIM, who's a senior system engineer in network innovation and a BBF principal member. And last but definitely not least, we will have David Allan, who is our work area director for the WWC work, and he's also a distinguished engineer within Ericsson. So let's get to the meat of the end of the webinar, and I'd like to pass over now to Christele, who will start off by telling you how we got here from a wireless wireline convergence work. Christele, can I pass the mic over to you?
Thank you, Greg. So, sorry, I have difficulties to change my slides here. So let's start by placing the context where it all started. So in 2016, we had operators approaching Broadband Forum with questions related to 5G and its implication onto their wireline network. More importantly, they were keen to know if the industry would be moving to a single 5G core or still operate two separate core networks, namely wireline and wireless. Following that, Broadband Forum approached 3GPP, and together we held a joint workshop to examine use cases, lay out goals, and establish way of working together. From there on, 5G WWC was born, both in Broadband Forum and in 3GPP. Since 2019, both Broadband Forum and 3GPP have been writing specification based on the previous year study period. It results in Release 16 being out there for 3GPP, while Broadband Forum released its Phase 1 specification document in July 2020. We have Guideline Principle that governs the work of 5G WWC. Firstly, we have a loose coupling in between the wireline access network and the 5G core, allowing both to evolve with a minimum impact on the 5G WWC architecture. At the same time, we have a zero impact on the access node already deployed. Secondly, we want to have a smooth migration path where we take into account current deployments with a step-by-step transformation going forward. And thirdly, we want to address as many use cases as possible and take into account the broad variety of business model to make sure that we address the largest market possible. So let us see now what the drivers for convergence are. First, there is an opportunity on timing. Indeed, the transformation of the wireless core is happening now. At the same time, there is another transformation ongoing in both wireline and wireless, namely the cloudification and control plane user plane separation, which 5G WWC can leverage for a faster and more efficient transformation. Then we have optimization, where 5G WWC allows an integration of functions and systems, as well as unification of the operation management and maintenance, and a convergence on application and services. At last, from a monetization angle, we allow new and improved services available to all customers. And of course, we do have a single core instead of two. So here is how the architecture is looking today. Today we have two separate networks. So you see here a wireless end user devices going through a 3GPP antenna and speaking to a core through N1, N2, and 3 interfaces. Those N1, N2, and 3 interfaces being defined and specified in 3GPP. The core, the 3GPP core, is also defined and specified in different functions. Then you have the wireline network, where you have fixed network routing gateway, speaking to the wireline network through either DSL or fiber technology, and going towards the BNG, the broadband network gateway. So what does WWC change today? So at first, we do introduce a new edge function, the access gateway function, AGF, that replaces the BNG and allows wireline users to access 5G services through the 5G core. Then we introduce a new generation of residential gateway, 5G-RG, which are wireline routing gateway behaving as 5G end-user devices towards the 5G core, using SIM cards for authentication and credential. Moreover, the N1, N2, and 3 interfaces have been enhanced in Release 16, allowing to plug in a fixed network. As Broadband Forum, we had to take some key decisions. For the FNG Support, which is a wireline residential gateway with no SIM card, we have decoupled the routing gateway rollout from the 5GC upgrade. Then we have decided that the wireline network would vouch for the routing gateway using line ID as subscription identification. And at last, we have proxied the 5G end-user device behavior to the AGF in order to minimize the change to the core. For the AGF, we have decided that an AGF would support both FNRG and 5G-RG at the same time. Moreover, a customer would be able to go back and forth in between a 5G-RG and a FNRG. The 5G WWC architectures allows to connect existing access infrastructure, so DSL and fiber, and their future upgrades, as well as future access technology. We also support layer 2 wholesale business models and government-regulated accesses. So here is how the new 5G WWC architecture is looking like. In yellow, you have all the new elements. You see here a 5G routing gateway that connects via the wireline network and the AGF towards the 5G core. You have also the existing fixed network routing gateway going through the wireline network. And here you have the proxy function that allows this to speak to the 5G core. We may have a 5G routing gateway, which is wireless only. That's called the fixed wireless access. It connects then to the 5G antennas and to the 5G core, where it will receive the traditional broadband services. And we have the case where you have a 5G routing gateway, which could connect both to wireless and wireline. We call it the hybrid use case. In the future, we have this branch here. So in the longer term, we believe that the wireline core network will disappear. As we mentioned earlier, there is a transformation ongoing right now in the wireline network, namely the disaggregation of the BNG. This work is done in the Broadband Forum in parallel of WWC. So the disaggregation of the BNG gives different advantages. First, a centralized control plane management that simplifies the operation. Then we have independent control plane and user plane lifecycle management, as well as independent scaling. And it also allows for interoperability in between different vendors, control plane and user plane. If we apply this control plane, user plane separation to the 5G WWC architecture, you see that the AGF is split in two. So we have the control plane and the user plane part. And you see that if we take the AGF user plane, so the wireline side, we could collapse it with the user plane from the wireless network. It goes together, it collapses, and the entry interface disappearing. So it means that I could have a further optimization of the network performances. So a few points to recapitulate this introduction of the 5G WWC architecture. First, the transformation of the wireless and the wireline network is happening now. We had and we still have a successful 3GPP Broadband Forum collaboration. We have introduced 5G routing gateway, so wireline routing gateway with SIM cards. We have introduced an AGF, access gateway function. It does replace the BNG with the correct end interface to speak to the 5G core. And we are going to a simplified architecture with a single 5G core serving multiple access technologies. Cloudification and CUPS is happening now in wireline and allows a further optimization. Ultimately, the 5G WWC architecture is allowing a convergence of function, services, and application from both wireline and wireless worlds. I leave now the speech to my colleague Laurent Thiebaut, who will be representing 3GPP view on 5G WWC. Laurent, up to you.
Thanks, Christele. And so, hello everybody. And okay. Now I'm going to present you the 3GPP view of the 5WWC. And this 3GPP work on 5WWC relies on the second 3GPP release for the 5G core, i.e. the 3GPP release 16. Thus, the 3GPP work for 5WWC did not start from scratch, but could rely on the solid architecture built as part of 3GPP Release 15, especially on the fact that the 5G architecture has been meant for the 5G core to be able to serve many different types of access network.
Laurent,
And
sorry to interrupt. It might just be me, but I cannot see your slides at the present second.
you cannot see. Can you see?
That is perfect now. Thank you.
Okay, sorry for that. And 3GPP, so the 5WWC had only small impacts onto the main interfaces of the 5G core, namely N1, N2, and N3. N1 is the interface between a smartphone, the signaling interface between a smartphone and the 5G core, and the 5G RG, be it for fixed wireless access or hybrid access, will support exactly the same N1 interface than a smartphone, with one tiny difference. Likewise, 3GPP define N2 and N3 as N2 as a control plane interface between the 3GPP RAN and the 5G core, and N3 as the user plane interface between the 3GPP RAN and the 5G core, 3GPP RAN and the UPF. And the AGF function, the split AGF function that Christele has presented to you, will support almost exactly the same interfaces, i.e., the control plane part of the AGF supports the N2 interface with the 5G core, with the access and management function, whereas the user plane part of the AGF supports the same N3 interface with the UPF than the interface that the 3GPP RAN supports with the UPF. Only very limited changes have been made to these N1, N2, and N3 interfaces. For example, we added some specific wireline QoS parameters control over N2. We added also over N2 the signaling exchange to support the possibility to collocate the access gateway function and the user plane function, i.e. The user plane part of the access gateway function and the UPF. On top of that, 3GPP did not only slightly update its N1, N2, N3 interfaces, it also introduced new functionalities to meet the BBF requirements. But the new added functionality were not that big and didn't require a big effort. But we nevertheless enriched the 5G core IPv6 prefix and address allocation mechanisms. And this enrichment has been done under requirements of BBF, but could also apply to smartphones. We have also added the possibility to configure the residential gateway with the address of the auto configuration server, the entity that terminates TR69, and this aspect is more specific to BBF. We have also handled the specifics of the legacy FNRG, especially the fact that it's a kind of UE that's not subject of SIM-based authentication and security. And we have added the necessary feature to support IPTV. And this corresponds to the support of IP multicasts in the UPF and the control of this IP multicast support in the user plane function by the policy control function and the session management function. We have also added a feature called ATSSS that I'm going to present to you in the next slides. And this ATSSS is for access traffic steering, splitting and switching. Okay, excuse me. Okay, so this ATSSS is not meant for legacy RGs, for FNRGs. So it's meant for an hybrid 5G residential gateway, i.e. a residential gateway that simultaneously support the 3GPP access, the radio access, and the wireline access. And this ATSSS is meant to support one data connectivity. So for example, one IP address where the traffic for this data connectivity, for example, where the data connectivity is to access the internet, where the traffic can simultaneously use both accesses, i.e. they may be at the same time flows, IP flows from the RG or from the household behind RG that are using, let's say, the wireless access, while other IP flows or even some other parts of the same IP flows, which would be using the wireline access. And this feature can provide throughput aggregation, wherein the internet access throughput would be the sum of the throughput that can be reached over the radio and the throughput that can be reached over the wireline access. But it can also support a higher service resiliency, wherein if one of both accesses is failing, the resistant gateway, once it has detected the failure, just needs to send one packet on the user plane, and the 5G core can then switch to ensure that all the traffic remains on the access that it's still working. And this feature has been defined by 3GPP with a broader scope, i.e. it has been defined in release 16 to apply not only to 5G RGs, but also to smartphones. But clearly, 3GPP had in mind this hybrid access case that I've just presented to you. Now, time to wrap up. So where are we at? So the current BBF work relies on the 3GPP release 16. The work was very cooperative and easy because it relied on the clean functional split between access and 5G core done as part of the 5G system. If you are interested in technical aspects of this work, you should read the TS 23.316, which is a 3GPP technical specification that's focusing on these 5 WWC aspects. And this, what we have presented now, is not the end of the story. We expect 5 WWC related future work that would require new 3GPP features, and those are expected to rely on 3GPP release 18. And I would say that it's a good time for BBF folks to express requirements, because 3GPP in the next 6 months will decide the topics that will be studied and specified as part of 3GPP release 18. And so any potential gaps or extensions required by or detected by BBF and required by BBF would be welcome. Having said that, I'm happy to hand the floor to David, who will present deployment scenarios.
Thank you, Laurent. Now I'd like to discuss some of the deployment scenarios that relate to wireless wireline convergence. So, from an operator's perspective, what's on your mind when it comes to deployment? So we've got some topics like, will my existing CPU be compatible? Can I reuse my existing BNGs? What about my network resilience? Will my customers be disrupted? Here's an example of an operator who has a native 5G solution. There's a couple of things to point out here straight away. It shows the power of control user plane separation. We have at the top row up here, we have our 3 control plane nodes. Okay, so in this particular implementation, we've gone for a geographic separation, and each of these 3 control plane nodes are capable of meeting all the needs of the 5 user plane nodes. Now, the 5 user plane nodes can be put deeper into the network. Now, if we put them deeper into the network, we can take advantage of things like local breakout, where we might have servers that support streaming media. Be a good example of that. But the power of all of this is by moving away from your traditional deployment, where you'd have control plane elements co-located with your BNGs, we're now going to move them out into the cloud, and we're going to make all of the control plane nodes capable of servicing the control plane needs of the AGF. And that's going to give us a whole lot more resilience, which we haven't been able to do with traditional deployments. Now, when it comes to migration, we're going to have a look at two views. We're going to have a look at the AGF view, and we're going to have a look at it from the CPU view. Basically, we've designed the migration strategy such that either can be replaced at any particular time and have it completely reversible. Now, the key to all this happening is in the UDM. We're going to store for each subscriber the line ID and the SIM. So our FNRGs are always going to make use of line ID, and our 5G RGs are going to make use of the SIM. So with this particular scenario, we can start to switch out our BNGs. So our access network can be told to stop sending traffic to a particular BNG and move it across to an AGF. Now, when we move it across to an AGF, the AGF runs in two modes. We have adaptive mode. That's going to support the FNRGs. We have direct mode that's going to support the 5G RGs, and they can negotiate that themselves. In the meantime, the custom has minimal loss of service. They don't need to take any further action. The operator is in complete control of this particular strategy. Now, from the CPU point of view, it's a similar story. Again, we're leveraging off this dual population in the UDM. We've got our mixed population of FNRGs and 5G RGs. And as an operator, you can start to ship out 5G RGs whenever it's convenient for you to do so, knowing that the existing population of FNRGs will be fully supported. So in the case of the FNRGs, they're going to be, regardless of whether they're connected to a BNG or an AGF, they're going to be operating in FNRG mode. That's the default mode. A 5G RG, however, if it can negotiate 5G RG mode with an AGF, will operate in 5G RG mode. If for any reason it can't, we're going to fall back to FNRG mode. So we've got the resilience necessary so that we have no customer that is stranded. And lastly, the customers can swap between FNRGs and 5G RGs at will. That means that should they feel that they're having issues with the new gateway, they can swap back to the old one. And as an operator, you don't need to provision anything to allow that to happen. That's a really important part of the resilience strategy. Now, let's have a look at the case of hybrid access. Now, hybrid access is not new for some of our operators, but previously it hasn't been a very elegant solution. Traditionally, hybrid access has made use of the fixed network and it's made use of a mobile network, and they've been completely separate entities. With 5G, we're able to harmonize that, and irrespective of which access technology you're using, you're going to be sharing the same properties. So it all comes down to your traffic ends up on the same UPF. Because it's on the same UPF, you're managed by the same SMF. That means you get to retain the same IP addresses. The network path from the 5G core out to the rest of the internet remains identical. We can actually swap from one to the other without the customer actually noticing. And lastly, we've got the capstone of all of hybrid access, which is A2SSS. Now, Laurent mentioned that in the previous slide pack, And I'm going to go into a few more of those use cases with that. So first use case, high availability. Okay, as an operator, we're always striving for a resilient network. And we can use a 5G RG in an active standby mode. So this is all predicated on the 5G RG detecting a loss of service. Now, some of us have moved to using IPOE for our networks. And one of the things that really noticeable about that particular change from PPP is we can't detect a loss of service until a lease expires. And that's been a big bugbear for a while. With 5G, we're bringing back the PPP LCP echo test. So we've got a liveliness test that will detect a physical loss of service within about 10 to 30 seconds, depending on how you set your network up. Upon detection of that, a 5G RG then modifies all PDU sessions to use that alternative access technology. It doesn't matter whether you're going from fixed to mobile or back again, we can switch it all based on that particular detection strategy. And because it's all integrated and we're using that original UPF, we're able to route the traffic back to that UPF, and we're going to preserve all the session attributes and connections within the applications running on the user's network. It is highly likely that they won't notice the change in network. So again, it's a better user experience for the customer. Another use case is preferred access network. Each access network has some natural advantages and disadvantages for that matter. But what we'd like to do is direct traffic to the most optimal access network. So one of the things that we get with 5G is the concept of policy. Now, policy impacts on a variety of areas within 5G, but what we're going to have a look at is URSP. Now, a 5G RG will receive a set of rules upon registration. And those rules basically have traffic descriptors in them that match services that the 5G RG could potentially support. And attached to each of those rules is a preferred network. So what a 5G RG will do is we'll run through those matched rules, and it creates a PDU session for each of those rules. That way you've got dedicated PDUs, which you may consider to be an IP session for each of the major services. An example of that would be general internet versus a voice over IP telephony service. And the 5G RG can be told to prefer one access technology over the other as part of those rules. So it's expressed in terms of using a 3GPP technology, i.e. LTE or NR, or a fixed access technology. And then the 5G RG simply routes the match traffic to each of the PDUs in question. Of course, we can swap back should there be network disruption, but having the preference there allows the operator to specify the best way to carry that particular traffic. Now, the last use case that I'd like to present is ATSSS. Now, really, it's a family of use cases, okay? And you can consider ATSSS to be a multi-access PDU architecture. So a couple of things that we can do here. So, now, taking into consideration that we've got multiple access paths, again, we've got a thing called an anchor UPF, and that's what makes it all work. We can split the traffic over these two legs and join it up at this point in our network. So we could load balance. We can have hot standby. Hot standby is great because we don't have to wait for the network to fail. We can simply measure the traffic performance. And that's another thing that happens within ATSSS. It's actively monitoring the state of each of the legs, and there are some predefined threshold points where you can say, this performance is below par, I'm going to move traffic around. So we make use of that for both hot standby, also for the optimum path routing. And the other one I wanted to mention is speed boost. This is a great one for operators who want to guarantee performance for a customer. So for example, you sell a VDSL service to a customer and you guarantee 50 megabits. That's great, right up to the point where the customer has a copper length problem and can't achieve 50 megabits. How are we going to get them to the guaranteed speed? We carry the rest of the traffic over the mobile network, and we fill in that blank left by the performance of the fixed network. So that's just an idea of some of the things that we can do with ATSSS. It's coming in the second phase of our wireless wireline convergence work, and stay tuned for more developments on that. I'd like to now hand over to Rosaria from Telecom Italia.
Thanks, Dave. So, my speech today will be mainly focused on the interesting gift that 3GPP as 3GPP specifications on 5G have donated to the industry. These specifications allow operators to design innovative services and develop new business models with the third parties that until a few years ago we could consider enemies. I will go through some of the 5G technical enablers that 3GPP has designed. I'm more a technical person than a marketing visionary. However, I will try to show with an example how these enablers listed here can be used as bricks to build new ideas for services and business models. Most of you can then unchain your fantasy and invent use cases surely better than I can. I would start with the trivial claim. For operators, traditional services are not enough for keeping the incomes at a reasonable level. Hypercloud providers such as Google, Amazon, Microsoft Azure dominate services through their clouds. However, their over-the-top applications do not bring any money to operators. On the contrary, the OTT compels operators to increment bandwidth in their networks and to update interfaces. On the other hand, hypercloud providers have developed a big ecosystem which continues to grow and offers many and varied APIs to third parties to develop new applications. Nowadays, operators are realizing that they need to explore new business models with the hypercloud providers to benefit from this ecosystem. One of the most interesting ways for operators to benefit from this ecosystem is to leverage their assets at the edge location, exploring new service delivery concepts. Hosting services at the edge locations gives great advantages in terms of low latency and rich bandwidth for the final users, something which hypercloud providers consider valuable simply because they do not have it. Service platforms at the edge location are very promising in the 5G context because 5G gives a complete toolkit to exploit these platforms. And I'll explain this with an example in a while. Before that, I wanted to first pause on a fact. With the 5G transformation of the industry, new business models, mainly based on revenue sharing, are arising. And this is happening now, like Christele said. So we have to seize the moment, finding and pursuing as much as possible the new revenue opportunities associated with these new models. In this slide, I wanted to make an example about how the technical enablers provided by the 5G core can be exploited for these phantom new services. Let's fix our ideas on an online video gaming service, but it could be any other service which requires low latency, like a working in cloud service or a live streaming service, whatever. Suppose a wireline or a fixed wireless access user wants to use his online video gaming application. The application is offered by a cloud service provider or a third party. The application detects the user request and has the possibility to interact with the 5G system to request the best quality of experience for the user that is using the application. The interactions between the application and the 5G system happen in a secure way via the network exposure function, which, by the way, is able to expose an information about the user, which is extremely useful to the application, the user location. The user location allows the application to identify the service platform closest to the user among those distributed in the network. Once identified, this platform, which might be deployed in a convenient point, as I said, closer to the user in an edge cloud, the application function, again through the network exposure function, can require to the 5G system the traffic steering for that particular user towards the local platform. This is possible invoking the configuration of the uplink classifier in the UPF closest to the target service platform. The UPF in general provides packet routing and forwarding, but when required to perform the role of uplink classifier, it is able to steer traffic flows to a specific data network on the basis of some traffic matching filters. These filters are received from the SMF, session management function, due to a decision taken by the policy manager function, PCF. So the final effect of all these interactions is that the traffic of the application for that particular user is intercepted by the uplink classifier and steered locally, while the remaining traffic is sent to other data networks. This ensures an overperformant quality of experience to the user of the application, with the great benefit for the application provider. Besides that, the application function can subscribe to analytics generated by the 5G core. Yes, because 5G core is a function that is dedicated to that. It's called network data analytics function. The application function might want to receive information about the latency that actually is experienced by the user, or information about the bandwidth consumed by the user. In general, the application function might want to monitor the quality of experience of a user who is using the application. To cut short how many enablers I have mentioned in this simple example: network exposure function, analytics, UPF uplink classifier, user location. But I've not invented anything new. I've just transposed concept which you may have heard within the 5G context. And notice that I did not talk about mobility. No doubt that there are applications that require mobility, but many of them do not. And finally, a last pill, slicing. Perhaps the most exciting innovation which will come with the 5G deployment is network slicing. Simply put, slicing will enable networks to be logically segmented to meet the requirements of specific services, such as guaranteed resilience, bandwidth, or low latency. For example, one slice could be configured to support low latency applications, while another one is created to ensure the highest level of availability for mission critical applications such as healthcare. Again, I wanted to highlight that most of these 5G applications do not necessarily require mobility. They can be offered through a wireline user equipment which does not support mobility. Slicing gives operators great flexibility to meet specific service needs while still using the same underlying network infrastructure. To deliver this promise, service providers need an end-to-end network slice orchestration solution, which can create and provision network slices. In other words, the solution must be able to handle the entire slice lifecycle. And this solution shall span the access, the transport, and the core network domains. Certainly, the slicing orchestration is associated to a lot of complexity, but it will be vital to support the catalog of new enterprise and consumer 5G applications. The basic idea to handle this complexity has been introduced by GSMA which has defined this concept, the concept of network type slice template, NEST. The NEST translates the qualitative service requirements, which might have been discussed with the customer, into quantitative technical requirements. It's a document, machine readable, which can feed the orchestration system, whatever the choice of the operator will be on this. Yes, because there are several standard bodies that are working to define the specification for network slice management. And I mentioned it here, HETC, 3GPP itself, TM Forum, and among the communities, we can mention ONAP, 5G Monarch. There are many. The orchestrator, whatever will be, will interact with the controllers of each of the domain involved to build the end-to-end slice, the access to the transport and the core network domain. Is it easy? Absolutely not. However, when all this framework will be ready, and we have learned that 5G is driving the industry much faster than many other technology. So when everything will be a reality, it will be even worthier to exploit the orchestration system for just another category of services, wireline services. So with that, I'll hand over to Dave, our work area director, Dave Allan, who will tell us about the journey we are making in BBF.
Thanks, Rosaria. It has been quite the journey getting to here, and it's been a very rewarding one. When we kicked off the work in 2017, studying exactly what would be involved. We had a plan to complete the normative work by 2020. Things did not quite work out that way, and this was for a number of reasons. First, we were focused on a true convergence play with minimum impact to the 5G system in order to make wireline work. This added to the work the BBF needed to do. Secondly, we included support for legacy residential gateway devices and ensured 5G access would be able to work with unmodified access equipment such as OLTs and DSLAMs. Third, we embodied network transformation in the set of behaviors we would support so that wireless wireline convergence itself would be an agent of change. And as wireline networks have never needed to be specified to the level of detail of the mobile network, that meant we had an awful lot to think about. Now, our response to this has been to split the work into phases. We published what we call Phase 1 in 2020. Phase 1 was foundational and underpins all of the future work. In Phase 1, we solved many of the hard problems, and in particular those around the transformation from today to 5G. What we covered was a lot of the basics. How the legacy residential devices could be supported by the 5G system. What the basics of a 5G-enabled residential gateway looked like and how it was going to be supported over existing access networks. How the 5G QoS, or quality of service, would map onto wireline networks. This is actually a fairly big thing because it provides operators with a uniform model of both delivering and charging for network differentiation. How legacy and 5G devices could coexist and each get the required network treatment, and how equipment upgrade could be seamlessly done. This required eliminating pretty much all of the dependencies between the various steps so that tight coordination of the steps would be eliminated. Now, as I mentioned, this work is published and it's publicly available on the Broadband Forum website. Right now, we're working on Phase 2. In Phase 2, we start to build on that foundation and get into expanding the deployment options and unlocking more of the value of the 5G system. So we are defining a new interworking option, the FMIF, which adapts traffic from unmodified BNGs onto the 5G core. We are specifying control and user plane separation to expand the ways this equipment can be designed and deployed. We're filling out the gaps for the deployment of ATSSS, which you've heard quite a bit about earlier. This is the 3GPP version of hybrid access. ATSSS has multiple traffic distribution mechanisms and policies, and this is a really strong use case for 5G WWC deployment, with a lot of interest from our operator community. We also have interest in voice on 5G to leverage the infrastructure that is there to help with the sunsetting of the last of the POTS network and converging voice onto the one network where it's never going to go away. And we're starting to focus on leveraging the enhanced service capabilities of the 5G system with network exposure and some enhanced legacy RG support features. And the journey won't stop here. We already have a backlog of items to consider for future releases. So to summarize, what we hope you got out of this webinar was that first, 5G is a huge opportunity for operators to converge their networks. Basically, they can streamline all aspects of network operations at the same time. And the name of the game in the longer term is to increase monetization of the network. Convergence enables this with a minimum of effort and allows operators to leverage all of their assets. WWC is a key part of that convergence. It is how wireless and wireline come together for a 1 + 1 = 3 equation. The Broadband Forum has rolled out the groundwork and will continue to drive value for the converged and fixed operators. The journey is continuing, and I would encourage you, if you're interested, to get involved. So over to you, Craig.
Thank you, Dave, and thank you, everyone. A great session, and we are well in time, so we've got some time left over for Q&A. And first and foremost, I'd like to thank all of our attendees for being really busy in the Q&A area. We've had 18 questions, and also thank you very much to the panelists who have made my life really easy by answering nearly every single one of them. So thank you so much for that. There's a few outstanding, so I'll go through those now. There's one here that I believe that Christele answered, but you may not have seen the answer. If we are talking WWC, is this suggesting to add the slicing concept to the wireline network, i.e. URLLC, EMTC, and EMBB? Who'd like to answer that one? Christele, I think you answered it first in the conversation.
Well, yes. So indeed, the slicing concept is something that we would like to see applied to wireline, and I think it has been touched by Rosaria. I don't know if any of other panelists would like to give more details, but so far the answer to the question is yes, slicing indeed would be a concept for wireline too.
I can add that the wireline access is one access from a 3GPP 5G core is one access like the others, and the N2 interface between the 5G core and any 5G access network carries the necessary slicing information, especially, for example, the set of slices that are allowed for a given UE. And when it's about requesting for resources for a data connectivity called PDU session, the 5G core provides the identity of the corresponding slice. All that means that both at the control plane and at the user plane, the AGF can receives the necessary slicing information and can then apply whatever policies that are related with these slices. At least that's the answer with, I would say, 3GPP glasses on, between brackets.
And if I was to add a little bit to Dave here, from the BBF's perspective, we have really focused on a convergence play. And one of the aspects of that would be the uniform availability of the 5G toolkit across fixed access, as well as the various other accesses that 3GPP is working with. So you would not be constrained at all by which access you were using in terms of your ability to apply services. And that really starts to make the 5G core into like a real platform. So we see this sort of thing as very important.
Fantastic. Thank you all for answering that one. Here's a question from Dan. Given a choice, why would an ordinary consumer purchase a 5G RG instead of a FNRG? Can the benefits be explained to non-technical customers? Rosario, would you like to have a chance at that one?
Yeah, I would like to take this because I had the same question when I embraced this journey. And the answer can be found in the fact that, of course, 5G RG can be also hybrid, but this might be seen as a niche case. But more in general, there is a limitation for FNRG to access to many data networks with different PDU sessions, while the 5G RG can request up to 8 different PDU sessions, and so it can access to different data networks through different slices. On the contrary, FNRG so far is limited to access to one network, to one data network and one slice, which is the default one. So we are trying in the second phase of our specification to overcome this limitation, but you also has to consider that from the FNRG to the AGF, so in the access network, you usually do not want to open more than one PPP, or in general your legacy session. So because the FNRG usually are able to open one session, or maybe the operator wants to limit to one session the FNRG, it's a little bit inconvenient and difficult to let an FNRG to reach more than one data network, while the 5G RG will be the complete toolkit that 5G has designed for final user equipment. So the flexibility, it's complete. Hope this answered the question.
No, good answer and great question. We've got time for one more. Sorry, Dave, did you want to add to that?
It was Laurent. Okay,
oh,
just
Laurent,
a tiny remark that 5G RG can also be used to offer wireline services in places where it's too expensive to bring the line, be it DSL or GPON, because based on the usage of fixed wireless access on 3GPP radio access.
That's physical connection cost, yes.
Yes.
Okay, we got one more question here. I've got time for one more question. Here's a very top level overarching question. Is there a list of key benefits in service providers' perspective? I see there's a TOC, a total cost of TOC in one, but what about in terms of dollars? Is there a dollar benefit from a service provider's perspective?
Yeah, I'll take this one, Craig. Well, there is a dollar perspective when you consider a lot of operators these days have two completely distinct networks with no ability to consolidate them whatsoever. So once you move to the 5G core, you start to get the advantage of having one network. and you can scale that up to what your needs come down to. And there's some other intangible things. So, for example, one of the issues plaguing all operators at the moment is address space. Now, if you're using IPv6, it's not a problem. If you're using IPv4 and you didn't grab some 10 years ago, you're in serious trouble. So how do you manage your IPv4 usage? If you've got two networks, then you've got IP resources stranded that could be better utilized on another network. So some other advantages along that front. You could also look at consistency of service. If a customer uses the mobile network, they'll get one style of service. If they use the fixed network, they get a slightly different style of service. Would be a good example of that. Authentication. If the customer's on the mobile network, the network operator has a better idea of who they are because of the authentication methods. And there's some techniques used with captive portals that that leverage that. That's traditionally not been that available on fixed networks until line ID started to become more prevalent. So consequently, you can have a differential experience for customers. 5G, it's a level playing field. There's some of the reasons why you'd want to go down that path.
Thanks, Dave. Well, we're at the top of the hour. So I guess that all that's left for me to do is to thank all of our panelists. Excellent session. Thank you all so much for your time, and to all of our attendees, thank you for all the questions. There's been so many that we will try to include them in our post-event follow-up email to you, so you have the answers there as well. And just to let you know that this is the first of actually 2 webinars in regards to our WWC work, and we are planning to go into a deeper technical dive on Wednesday, the 5th of May. So keep your eyes open. We will be sending out invites to that for the 5th of May in the following week's time. But once again, thank you very much to everybody involved. Great to speak to you all soon. Take care.
Thank you.
Thank you. Bye-bye.
Thank you.